Hi, my name is Paiton Pumroy.
I'm Sydney Wetlaufer.
I'm Tatum, Englund.
And I'm Miranda Wood. Dyersville Diecast is located in Dyersville in Farley, Iowa, and is known for their 5 decades of die casting.
They specialize in custom aluminum die casting, just like the parts we made in IE 348.
During the die casting process, aluminum bars are melted using individual furnaces and a large central melt. The furnaces used in the facility generate a lot of heat, putting the employees at risk.
Recently, OSHA has published a notice of proposed rulemaking. The standard requires employees to implement control measures above an initial heat trigger at 80 degrees Fahrenheit and additional measures above a high heat trigger of 90 degrees Fahrenheit.
Our team was tasked with creating a safer environment for the employees and getting ready for the proposed legislation. The objectives for the project come from a combination from Dyersville Diecast and from our team thinking of things that would be beneficial for the company. The first objective is to maintain the Farley facility temperature to not exceed 90 degrees Fahrenheit. The second objective is to improve the internal air quality in the Farley facility while maintaining the air quality emissions. The third objective is to increase the safety score to 90% using their internal audit system.
To better understand the problem, we focused on 4 areas for our current state analysis: safety,
Temperature,
Air quality emissions,
And airflow.
During one of our visits, we conducted a departmental safety audit using their internal system. Their safety score was 37.5 out of 50.
Using 6 Govee thermohygrometer sensors placed around the facility, we took temperature samples from key areas where employees would be located. We found that over 97% of the 600 plus temperature samples near the central furnace were above the high heat trigger.
Talking to experts in the field, we calculated the emissions throughput to be 1.96 tons per year. This was below the EPA and DNR standards, so our solution will be focused on maintaining the current emissions in the facility.
For the airflow calculation, we calculated the cubic feet per minute in the facility using this equation. To maintain 85 degrees in the facility during the winter months, we need a CFM of 85,127. During the summer months, we need a CFM of 564,685. For our future state design, we made our recommendation in 4 different phases.
Phase 1 includes changing the existing fan direction to be one directional, installing a temperature monitoring app like the Govee app we use for our analysis, as well as installing a new eye wash station and additional safety features for fire extinguishers.
Phase 2 includes replacing the existing 3 fans with a 57-inch Mag Fan 3 and also isolating the central furnace melt. This will require installing a ducting system, piping, and a no-loss stack.
Phase 3 includes increasing the number of fans, adding additional fans focusing on the center aisle and working outwards. Installation includes electrical and cutting into the sidewalls.
The fourth phase includes adding center aisle fans inside the facility. It also includes adding hazard markings for the remaining high heat areas.
Through our phased approach, we calculated the initial investment of all phases to total $176,437.40. The annual cost, including maintenance and fan energy consumption, is estimated to be $112,190.50. If this project were to be implemented over a 3-year period, we would expect the costs to be $513,000 or $171,000 per year.
The savings for DDC come from cost avoidance measures. According to OSHA, a heat prostration claim costs roughly $38,000. The cost of replacing a skilled worker can cost companies $20,000 to $40,000. And DNR fines for air quality emissions were estimated at $10,000. If the company were to shut down for heating issues, it would cost them 12,000 parts per day.
If we estimate a worst-case scenario where the company receives 2 OSHA complaints, turnover of 10 employees, 1 DNR fine, 5 days of shutdown, and 1 year, we estimate the cost would be $486,000. Over a 3-year period, the company would lose $1,458,000.
If Dyersville Diecast implements our solution, we estimate their savings over 3 years to be $944,991.10. But the biggest impact was improving the safety and well-being of the employees in the facility.
To everyone who has helped us with this project, thank you!